Mr. Wang 王老师现在是在一所顶级的女子私校在教12年级的 Mathematics 和 Specialist Math。那么这个学校呢，在去年的 VCE 高考当中一骑绝尘，非常厉害，非常 outstanding 的成绩。好的，那么我们把时间快速的交给王老师。
Am I starting now?
Yes, please.
Welcome everyone. Now let me just introduce myself first. I have been teaching in Victoria in high school in year 11, year 12 maths for over 20 years. So I had lots of experience. I have been these methods second exam marker for about 5 years, and the last 10 years I have been marking specialist maths exam too. So probably I have over 15 years of those marking experience, and I have so my job here is basically, so if some people think, okay, the students come to my class 2 hours a week for methods or 2 hours a week for specialist maths, that all of a sudden they can get 40. I mean, seriously, you are in the la la land. We're talking about, especially talking about the methods, is the most competitive subject in the entire VCE, because every 99.95 students will pick methods as their subject. So you're competing with the most talented students for this subject, and only 9% of people will get 40. And we're talking about in entire Victoria, we have 15,000 students doing methods. So you do the maths. So if you're not in the top 1,000 students, and then you won't get 40. And also we have in Victoria, you might not know that we have 500 high school, including country Victoria and tiny school. Imagine every school, doesn't matter how bad they are, if they have 2 top students, they will be very quickly fill that 1,000 place. Okay, so it's very competitive subject. If you are loving maths, and also I have to be honest, not everyone can do maths. Probably if you're talking about methods and a specialist maths, we're dealing with very high level of maths, and it covers calculus. Okay, lots of branch of maths. So honestly speaking, probably 20% or 30% the population can deal with this, can understand this. But if you are loving maths and you think you are simply join the exclusive club. And then in order to get 40, you really have to do lots of hard work. If you're talking to those students have got a 50 or high 40, those students, they won't tell you how much money, so how much time they spend. And they probably tell you they spent very little time on maths. But I'm telling you, this is a lie. Okay, they don't tell you the truth. They spent hours. They go through the textbook. We're talking about we're using 2 textbook methods, and both methods and specialist maths. We're using essential textbook. They have so many difficult questions. Those people who got above 40, they basically have done all of them. All those questions. Not only that, they have done past 20 years of VCE paper, and they probably have a private tutor as well. So that's the reality. Every students are competing with those top students. So, but my job here, so then you must say, oh my God, this is so difficult. How can I be improved? So my job here is, obviously we're doing only 2 hours a week, is simply to make sure you understand all branch of maths. Now you will later on, I will give you a couple of those examples from VCA paper last year's methods and specialist maths. Those questions, especially talking about the last question in first exam, they involve all branch, lots of branch of maths. So talking about geometry, talking about the analytical geometry, and they talking about a calculus. They can talk about any, they're dealing with any kind of different areas of maths. So my job is basically to make sure that I know lots of people coming in as a year 11, year 12 students, they have lots of gaps in their knowledge, and they probably don't even know. Okay, so but my job is to fill all those gaps, make sure you understand every sort of branch of maths we're dealing with in methods and specialist maths. And also, I will show you the variety of the questions. Let's be honest about it. No one here is a genius. We're only, if mathematical genius, we're only talking about Leibniz, we're talking about Newton, we're talking about Euler, Gauss, and so all those, they are the genius. We are probably just slightly above average. So you do, so imagine for the 99.999% of students, if you give them an unfamiliar question under test condition, and they will fail. And that has been sort of demonstrated in last year's specialist maths exam. Also the previous year, 2020, the methods exam. So both the exam, they present some kind of unfamiliar questions to the students, and then the result is absolutely poorly because I'm marking the exam, so I know. So basically, so therefore, the main job is to show you the variety of the questions. So hopefully the students has to be exposed to those different kind of questions. And there's not many people can deal with those unfamiliar questions under text conditions. So that's my job. So I'm going to try my best to show you all the variety of the question. Hopefully we covered all. I mean, but it's almost impossible to cover it all. So because if you look the methods and the specialist maths exam, they always couple of those questions, you have never seen them before. Even for me, I haven't seen them before. But then basically, because we as seasoned mathematician, experienced mathematician, so we can deal with it in 5 minutes. But most of the kids, they found it very difficult and challenging. Okay, so now. And so now let's talk about how do I do those 2 hours lesson, because I'm surely I can't do this just like your normal classroom teacher. They see you five hours a week, they can see you every day, but I only see you once a week. Now I'm going to using the notes. We cover the notes I use here in this school is the same as I use in my normal high school. So we go through the notes quickly, the theory quickly, then we go through those, I will pick those hard questions to go through in the class as well. We have sort of question and answer section. So let's say we're talking about those theory. We have to cover theory very quickly because we only have 2 hours a week. So once we cover the theory quickly, so then we will go through those hard questions. And then we might have a small test in every chapter. So make sure everyone can do those questions. And the sequence of this, the topic is I strictly follow the textbook, both methods and specialist maths, Cambridge textbook, because maths is a sequential subject. I don't want to sort of jump to start with chapter 10 first, and then you go back to chapter 2, chapter 6. So when you do jump all over the place, you do have some trouble to deal with this, because the textbook, those teacher has already take care of those sequential sort of issues. So because maths is very sequential, you can't do chapter 10 without doing first 9 chapters. Okay, so this is basically what I'm going to do. Now, I'm not going to talk about all the structure of methods and specialist maths. I guess everyone is very clear on those topics. So now, so I'm going to use, so I was given about 20 minutes each sort of to give you a sort of impression how I teach. So I picked up last year's methods first exam paper last year at the very last question. So I'm going to share with you this question. So I'm going to go through this question. Then you go through this question and show you the variety of the solution for this first part. Then you probably have a glimpse of how I teach. Okay, so that's I'm going to do that. So I'm going to share. Hopefully I can still do this properly. Share. Okay. All right. So this is the question. Olivia, can you see this question on the board?
Yes, perfect.
Okay, so I'm going to go through this question very quickly. So now this is the exam 1, last year's exam 1. So the last year By the way, last year methods exam is a lot easier than the previous year, 2020. So 2020, they made it very difficult. So last year's question is slightly easier, but when we're talking about the last question in school, a little bit challenging. But it's very well designed question. So because those people who write those exams, I'm sorry, just have a drink. Those people write those exams, obviously, the most experienced teacher, they cover lots of branch of maths. Now let's talk about this question first. If you look at this question, quite simple. Okay, so we have a circle, and because as I said last year, the paper is not difficult, so they give you the very nice number. Okay, so they reduced the complication of those algebra. Okay, algebraic manipulation or numerical manipulation. So they give you x squared plus y squared equals 1 instead of r or whatever 1. Okay, radians is 1. And then they say that the tangent going through a point P is on the circle and going through A, which is 2, 0. And they show that the equation of the line path through A and P is given by this. They want you to show this. Now, when they say show question, so this is a very important, when we mark this type of question in VCE, they say when you see these words show, you have to show every steps, because we know that we gave you the answer already. So you cannot skip any step. You cannot omit any steps. Even from first step to second step is so obvious, you still have to show, because this is show, we give you the answer. If we say work out the equation, then you can skip lots of steps. But this is a show question, all the steps is needed. You cannot sort of fudge anything, okay? So now, then we look at this question, because this is the last question. So majority of the people think about a calculus because we're talking about a tangent. The tangent, so which is very correct, a tangent. So the tangent to a curve is a gradient instantaneous. So the tangent, the gradient of this tangent is the derivative at this particular point. They're using this concept to work out this question. Now it is brilliant. Can be done very well. So I am going to show you these most popular methods, but not necessarily the best methods, by the way, but this is the most popular methods they do. Okay, however, you look at this question, I cut paste the VCA paper. They only give you 1, 2, 3, 4, 5, 6 lines, very small area. But let's just using calculus to do it. To use the concept of tangent. The gradient of the tangent is instantaneous rate of change at this particular P. Okay, so once we work out coordinates of this P, so then we can work out this gradient of this line. Once this gradient is done, then we go through 2, 0. So eventually this tangent is done. So that's the concept, that's the idea, which is a perfect idea. So let's just do this. So the aim is to work out coordinates of this P. So let's have a look at this P. So we make this X. And since this P is on the circle, so Y coordinates obviously has a relationship of this P. So Y coordinates obviously is square root of 1 minus X squared. And now I'm not going to put a negative because this is in the first quadrant, so it's positive. So from this equation, Y squared equals 1 minus X squared. So Y equals positive negative square root of 1 minus X squared. But in here, the first quadrant, we only have positive. So there you go. So this is we want to work out the coordinates of this P. So let's work out this. So we know the equation is Y minus 0. So because they go through this point 2, 0. So equals M X minus 2. So we basically have to work out this gradient of this M. And that M is the gradient of the tangent is also instantaneous rate of change at this particular point. So we write this M equals derivative. Okay, we do dy dx. So now the derivative of this equation, so this need a little bit of skill. So we have Y equals, I'm going to be positive. So square roots of this. So instead of write square roots, I'm write 1 minus X squared and a half. Now we do derivative of this. So involve chain rule. Okay, so we have half 1 minus X squared negative half. By the way, this is the first exam, no calculator is involved. So you have to do it manually. Times negative 2X. So this is a chain rule. And now very quickly you got that equation. quite nasty equation have so this become x divided by 1 minus x squared. So that's the derivative from this particular point. That's the gradient. Now remember, there's a different way to work out a gradient. There's two ways to work out a gradient of the strict tangent line. One way is derivative. The other way is using rise over run. Okay, so there's m can be written another way. So which rise over run? You have 2 points, p and a, that go through this. So y2 minus y1. So we have, so the top is 1 minus x cubed minus 0, and denominator is x minus 2. Now, these two equations has to be the same because we're talking about the same gradient. By solving this equation, we work out the coordinates of p, so which is x. Once we work out x, we can work out y. So there you go. So the next step is how to work out this equation. Again, looks very complicated, but actually is a very, very simple. So you write x square root of 1 minus x squared. So we might write negative over here. So that's basically 1 equals 2. They're same. Okay, then we have this and x minus 2. Then quickly see the cross multiplication very quickly. So this square roots cancel out. So 1 minus x squared equals negative x squared and plus 2x. Quickly you got that x equals half. Okay, very simple. X squared cancel out, x equals half. Now once x is half, so the y coordinates, you sub this into the circle. So 1 minus half, so 1 minus half squared, so 1 over 4. So y is square root of 3 over 2. So that's the point of p. So I'm just going to write it. So therefore the point of p is half and the negative, so square root of 3 over 2. Then you have, so the gradient, you can work out a gradient. You sub this gradient to rise overrun into here. So we very quickly work out that this is negative square root of 3 over 3. Then you sub this equation in. So therefore, the tangent is negative square root of 3 over 3, x minus 2. Now that doesn't look exactly the same. So I might write this is negative 1 over square root of 3 because they're same. And then you expanding this. So it's negative x divided by square root of 3 and plus 2 over square root of 3. You will get that done. Okay, in relatively, 5 minutes, probably, no, less than 5 minutes, you can finish this off. Okay, so this is the first most common methods people use. Okay, so this is the first methods we're using calculus. So people automatically think about a calculus, which is the huge branch of the biggest branch, the most difficult branch of maths you have learned in methods. Okay, that's you get only 2 marks. You have to write all of those. You have to show all of those. But having looked at this question, so if we don't think about a calculus, and the aim again is very clear. We want to show this equation. We already have a 1 point. As long as I know the gradient of this equation, this job is done. Now we can use geometry because we know, now even this question, they give you a hint already. They draw the picture, this tangent from the circle to, so the tangent from this particular point to the tangent P. So this is 90 degrees. We already, they don't even have to show you this is 90 degrees, but they actually give you a hint, this is 90 degrees. So here, OPA is a right angled triangle. So in order to work out, so very quickly, I know this radius is 1 and this length is 2. So I can work out this angle straight away by using trigonometry, basic trigonometry, year 9 trigonometry. Not even any harder. So opposite is 1, hypotenuse is 2. So I can get very quickly sine theta equals 1 over 2. So therefore this theta is 30 degrees. Now, once this theta is 30 degrees, so the gradient of this line is this angle tangent of this alpha, which is 150 degrees. So once I've got that, so therefore M is tangent 150 degrees. 150 degrees give you negative square root of 3 over 3. Okay, so give you 1 over square root of 3. Therefore, the tangent is y minus 0 equals this 1 over square root of 3x minus 2. Now, in this is the best method. You only so then you write IE because you want the perfect form. So y equals, you expanding this negative 1 over square root of x and plus 2 over square root of 3. Now, I haven't used any knowledge of of calculus. The only knowledge I have used is up to year 10. I use the trigonometry to work out an angle. Then using analytical geometry to work out a gradient. That's done. So this is the simplest methods. Lots of people overlook this question. You're using calculus, which is correct, but actually can be done very neatly and easily. And very few people actually did this way when we mark this exam. I didn't mark special methods, the 1, 2, but my colleague, one of my colleagues, marked exam 1 paper. She telling me she has been marking 500 because every paper is marked twice. So overall, she marked more than 500 paper. Not even one student she marked get full mark for the last question. That's how badly they have done. Even we made it, VCE made last year's paper really easy. Okay, the last question, not even one got everything correct. Okay, so this is how badly they done. So this is the first part. The first part are push. So then some people might think, is there any other methods you can do this question? Yes, I'm not going to write this anymore, but I'm going to give you a hint. You can even using discriminant, the idea of discriminant, because you have this line, so I'm just going to write here. So this line, y equals mx minus 2, and you have x squared plus y squared equals 1. These two lines, one is straight line, one is circle. Those two mathematical equations have one intersection. So therefore, if you sub this into here, so if you have x squared plus m square x minus 2 square equals 1. For this quadratic equation, the discriminant has to be equal to 0. Once you work out a discriminant, so from this equation, you can work out m equals -1 over square root of 3. Once you work out this m, this job is done. So there's 3, at least I can think of 3 different methods. And these methods, again, we do not using any VCE idea. We only use up to year 10 maths. As long as you have learned quadratic equation, you know a line with a circle, so we can eventually become a quadratic equation. This equation have only one solution because we're talking about a tangent is one intersection. So therefore, the discriminant has to be 0. So again, you can work out very easily. So for this first part, at least you can have 3 different methods to do it. So therefore, I am saying the more branch of maths you know, the more knowledge you have, and then the variety of the solution you can provide, and the easiest solution you can get under text condition, under exam condition. You don't have to think about it too complicated, especially this is the part A. Oh my God, so let me have a look at this. The time-wise, I'm not quite sure the time, so probably I talked too much already. I can keep going on the second question. Probably I'm not going to, I prepared, but I'm not going to go through B and C anymore. Again, the B and C, so if we just quickly go through what's the B question and the C question. B question basically is talking about this tangent. They say the tangent, so they do the transformation first. So this is initially tangent line. Then they have a transformation of this tangent line to work out a Q, a variable of Q, and make sure this tangent has 2 intersections to the circle. Now, again, and I can give you from personal experience, one of my top students, she got a 47 this year. Last year, she made that question wrong. So clearly there's a, initially when I was saying there's a gap, always mathematical gaps in your knowledge. Now, I didn't teach her year 10, I didn't teach her year 9, I only taught her year 11 and year 12. Year 11, because she's year 11 students doing methods. I taught her year 10 when she was doing accelerated unit 1-2 methods, and taught her year 11 as a specialist math student. So I didn't teach her circular theorem. So now here, when we're talking about it, so basically a circle, we have a point here, you draw this line, so this is tangent, you draw another chord, so they have 2 intersection. here, two intersections. But she forgotten there's another intersection you can have. You can have a negative as well. She only did the first part because this Q is R, cannot be 0. R is a real number. And lots of students didn't realize this R is real number. They don't understand the symbol. R is real number, can be negative. So she actually forgot this, the bottom half. Now this, in methods always, in the first exam, it's total 40 marks. The mark is always very, very mean. They only give you 1 mark. If you don't even get the first part perfectly correct, and the second part, no second part, you lost 1 mark completely. Even you're half right, okay? So she lost this. So once she come out of the examination, so I show her the solution because I did the solution very quickly. She said, oh, Mr. Wang, I forgot the bottom part. I said, how can you forget this bottom part? This is the theory of the circular theorem. From one point to draw a tangent to a circle, you can draw 2 tangents. How can you only draw 1? Clearly, they haven't been exposed to this knowledge of the circular theorem in year 10. And lots of schools, they don't teach circular theorem. They don't teach geometry at all, or very little of the geometry, which is detrimental. So therefore, I'm saying I am here to filling in those gaps. I'll make sure you understand this theorem. So once you understand this theorem, so you can't miss the bottom part. Then you will get this Q value very, very quickly less equal than 1. So then obviously cannot be 0, so Q cannot be 0. So you can write this equation. So I'm not going to go through the detail. So eventually you have this Q equals -1 to 0 and union 0 to 1. So you get that 1 mark. It's very complicated. So the second part is even harder. So I don't think I have time to go through this. And I'm going to stop here, and it's 2:28 already, so we only have about 5-6 minutes. So if you have, now this is basically a glimpse of how I go through those exam questions, and especially VCE question. I present the variety of the solution and tell the students what the key concept you can use and how do you present your solution. Very important, because constantly you have to show this question, not only in methods, you have specialist methods as well. So I show those kids how you actually present your solution properly in order to not to get penalized. Because when a VCA mark, all the teachers are marked very, very brutally, let me tell you. So especially 1 mark, if you get a tiny bit of wrong, you don't get it. Okay, there's no half mark award. Okay, so it's very important, the technique. How do I present your solution neatly and correctly? Okay, so this is very important. Okay, I'm about to have 5 minutes, the last 5 minutes. I can talk all day, but I'll just give you a chance to ask me any questions.
Yeah, thank you, Mr. Wang, for the explanation about last year's examination. I was so surprised about this question. It can be solved by 3 different ways. Wow, 太厉害了.
This is my job. I'll show you a variety
the
of
shortcut.
I know the second part of the question. This solution is absolutely beautiful, and not many people do it. So the tiny, very basic geometry, sort of trigonometry. Yes. Or you can say it's a geometry as well. So very simple, 3 lines. Take 30 seconds to do it. If those people doing Euclidean geometry, you wouldn't know. Now we don't teach Euclidean geometry in Victoria, which is so sad. Euclidean geometry clearly talk about if a right angle triangle, if the hypotenuse is, so if the opposite side is half of the hypotenuse and this angle is 30 degrees. That solution basically can be proved by trigonometry as well. So we're using trigonometry to do this. So, but if you have lots of idea, the Euclidean geometry, if you're familiar with those different branch of math, you can see through the questions from different angles, very, very differently.
Great, fantastic.